Good afternoon. I'm going to present you today Dockerizing your Jenkins platform, why it's important. So my name is Cyrille Leclerc. I'm French, as you can hear from my accent. I'm a director of product at CloudBees. Last year, I've worked a lot on Docker integration with Jenkins. I've worked with Docker Inc., with Red Hat, with Google on Kubernetes, with Amazon ECS, on others. I have learned many things on how to integrate Docker with Jenkins. So first, this presentation is about how to Dockerize a platform. We have two ways to see Docker on a Jenkins platform. One angle is to see how to leverage Docker to transform the infrastructure of the Jenkins masters, the Jenkins slaves, the continuous delivery platform. On one other angle is to see how I can build Dockerized app on my Jenkins platform. So these are two angles. Today, I'm going to cover the first part, which is how to leverage Docker to transform my CI/CD platform. The agenda today, first, we will have a bird's eye view of a Jenkins platform to be sure that we talk about the same thing. Then we will cover how to Dockerize Jenkins. What do we want to Dockerize? Why do you want to do it? What are the benefits? And how we are going to do it. So we will cover masters on agents. Once we have seen this, we will see something which is very important, is how to set up these environments, how to customize your build agents, how do you install and manage your tools, your credentials, your configuration settings. These things, the way you manage these things is different on a Dockerized environment. Then we will cover how to manage the Docker images. It's also a very important part. We will see the role of the Docker registry in this new CI/CD platform. And I will propose you a model of architecture of this Dockerized Jenkins platform. So first, I will ask a question. Who is using Docker today on his Jenkins platform? Can you raise your hand? Not that much. OK. Who is familiar with Docker? OK, a Docker file, Docker swarm, the concept, Kubernetes, ECS. OK. Thank you. So let's start with a bird's eye view of a Jenkins platform. We have a Jenkins master. We have build agents. We used to call them build slaves before. Typically, we have a source code repository. It can be Git or something else. We build the code on Jenkins, on the agents, and then we will publish the artifacts that we have produced on a repository of artifacts. It could be something like JFrog or Nexus. These two vendors are here during the conference. It could be another repository, maybe for NPM packages or whatever. And once we have stored these artifacts, typically, we will want to deploy the application to servers. There are all sorts of tests also that are involved in a CD pipeline and so on, but I will simplify with this diagram. Today, we are going to discuss about the Jenkins masters on the build agent. This is what we are going to Dockerize today. If you have any question, please feel free to ask and to interrupt me. So let's look at this platform. Jenkins master, it's quite simple. But then when it comes to Jenkins agents, we cannot simplify saying it's just 3 Jenkins agents like this, because you will have different flavor of operating systems. So maybe you need some Ubuntu because you find it convenient, and then you need a special flavor of Red Hat Enterprise Linux to create an RPM package, or maybe CentOS, maybe Windows, maybe macOS to build iPhone applications. And it's not only when you have to manage build agents, it's not only about the operating system, but you also have to install some software. If you like to do some Selenium web browser-based test, you will want to install a specific version of Firefox or of Chrome maybe a version of Internet Explorer on a Windows box, things like this. So we see that the agents that we have to manage, typically it's hard to have general purpose agents, and we usually have to have specialized agents. So a quick question, in your organization, on your Jenkins platform, how many flavors of agents do you have to manage? Something like 0 to 5 flavors of agents? 5 to 10 flavors? Okay, so we see that we have to manage lots of different flavors of agents, and so it comes with a cost, because dev teams, they always come with new requirements. I want to install this new software that requires root, like ImageMagick, which is a nightmare. It's just to resize images, but you have to be root to install it. Or they want a special flavor of an operating system. On the Jenkins admin teams, the people who manage these agents, they try to cope with the request, and they try to reduce the number of servers that are up and running. And there is something else which is very important and that I didn't mention, is the credentials on the configuration files. So, for example, in this room, how many people are storing Maven configuration files, the settings.xml file with the secrets to push to Nexus or JFrog on the build agent themselves? Somebody is doing this? Yeah. Yeah, it's hard to manage. Some people are storing SSH keys that are trusted to push on production server or test servers to do SSH connections, things like this. Yeah, and maybe it's not desired, because if it's on the agent and this agent is multi-tenant, then it means that you have to control who can access to this agent. Otherwise, you will have uncontrolled, unsecure access. So this is all credentials on configuration files. So we have seen this platform now, how to Dockerize the masters. Why would I want to Dockerize the masters? What would be the benefits? So this is a typical setup, simplified with the agent and the master. The way to Dockerize this, I propose, is to say that now we will have several Linux hosts, and we will Dockerize so that multiple masters will be able to run on the same Linux servers, maybe a VM, maybe a bare metal server, and I will have multiple masters running on the same host. So what kind of benefits do you expect from this? Any proposal? No? So here, what I propose you is that instead of typically on when we install masters, we have one dedicated server, virtual machine, EC2 VM per server, because we want to isolate the masters one from the other, file system, network ports, and so on. And here, what I propose you Dockerizing the masters is to have a better density. Because with Docker containers, I will be able to start 2 Jenkins master, 4 Jenkins master, maybe more, on the same Linux box, and I will be very confident on the isolation, network isolation, file system isolation, all this kind of isolation. Docker will help me to implement this and will solve this problem. And then another benefit, so who in this room is managing what we could call very big masters with tons and tons and tons of jobs on users, because it's hard to scale out? Okay, and who is facing problem like garbage collector or slowness, responsiveness, or teams who want different versions of plugins, teams who want to upgrade often, teams who don't want to upgrade often? Is it a problem? Okay, and here what I propose you, thanks to Docker, it's much more easy for me to manage multiple small masters. And here, these small masters, I will be able to scale out on each team or each group of users, each organization which will have its smaller master. They will be able to manage a version, choose a version of the plugin that they want. They will be able to upgrade when they want. And it will be much more easy for me as a platform administrator to manage these smaller things rather than these very big things. okay? So these are typically benefits that I will get managing my masters, smaller masters in a Dockerized environment. But I will also face challenges. If I manage multiple small masters, then I will need to manage a configuration of much more instances than if I just have one or two very fat masters. It's like mainframe with small Linux servers. To manage small Linux servers, we had Chef on Puppet or Ansible on these tools that help me. And here I will find a solution to manage the configuration of multiple masters. And then I will have another challenge, is that I will have to manage my Docker containers. So maybe I will be very happy with Docker engine, which is a standalone Docker runtime. But maybe I will want to have a more sophisticated solution. You may have heard of Docker Swarm or Mesos, Kubernetes, Amazon ECS. All these solutions, they are very valuable, very interesting, but I will have to choose. And choosing such an infrastructure component is not easy, and then I will have to learn. So these are some challenges that I will not undermine. I will propose you some solutions a little bit later. Okay? So we have seen benefits and challenges to Dockerize masters. Any question on this, or now I can cover build agents, which is the hard part? Okay? So Dockerizing build agents. If we remember the build agents as we have seen on this diagram, they are maybe Ubuntu, Red Hat Enterprise Linux, some of them have Firefox, some of them have some special flavors of Chrome, some of them have some specific secrets, password to access to this test database, some others have certificates, X509 certificates, SSH keys, and so on. And I will want to Dockerize all these things. One note, I will not be able to Dockerize Windows agent for the moment. Neither I will be able to Dockerize macOS agents. So we will exclude them, but I still think that we can get great benefits of Dockerizing the other components. There are two ways today to Dockerize the build agents, two major ways in Jenkins, because this is a very new domain, so we are exploring different solutions. The first way that I will propose you is just to take your existing Linux box and to install a Docker engine on each of them. The other way that I will propose you, and I will refine later, is to completely replace the Linux agents, the Linux servers that I have as build agents. I will replace them by Docker containers. So we have two strategies, and I will cover each of them. First one is Docker engine. So here, I like this solution. It's very simple. I take my Linux agent. It can be Ubuntu, it can be CentOS, RHEL, and I will just install a Docker engine on it. So apt-get install Docker or yum install Docker, things like this. And very quickly, I will be able to transform my infrastructure. And the way I will use these Docker capabilities on my Jenkins platform is with Docker pipeline and with this simple piece of code that you can see, this simple Groovy script, which is Docker image. I choose my image, for example, Maven 339. And inside this image, I will run, inside this container, I will run some pipeline steps. So during these days of Jenkins World, we have talked a lot about pipeline. And with pipeline, it's very easy to integrate Docker like this. Here you can see Maven 339, so this is for Java developers, typically. There are refinements. You have a Maven image with JDK 8, a Maven image with JDK 7, and so on. And you will be able to combine all the Docker images that you want. To combine in the sense that you will have first some steps in a Maven container, and then some other steps in a Selenium Firefox container, and then some step maybe in an AWS CLI container. Okay? So the syntax here, I feel, is quite straightforward. It's quite intuitive. And as I've said, it's very simple to implement this. Just have to SSH to the box. You keep the same infrastructure, and it's done. Okay? So this is the first proposal. Now we are going to look at the second approach, which is to replace the existing Linux agents by Linux servers with a Docker orchestration service. So typically here you have all your existing agents, and you will introduce some new agents, some new hardware, which will have an orchestration service. Maybe it will be a standalone Docker engine on a big box. Or maybe you will use Docker Swarm or Kubernetes or Mesos, Amazon ECS. And so on this Docker orchestration service, you will be capable to start multiple Jenkins agents. So the Jenkins agent itself is a Docker container. When on my previous slide, the Jenkins agent was a Linux slave, and inside the pipeline, I started some containers. And here, if you are familiar with the Jenkins agent management, we have these cloud agents, typical cloud slaves. Typically, they were EC2 slaves, Azure slave, OpenStack slaves, VMware slaves. And now I will have a new flavor that will be the Kubernetes slave or Swarm slave, and so on. Okay? So this is the second approach. Let's look at some challenges of this solution. The first challenge is that you have to choose your Docker orchestration service. So this is quite similar to what we've seen with orchestrating masters. Do you want standalone Docker engines? Or do you want a unified vision of all your servers that are capable to be Docker agents with Kubernetes, Mesos, Swarm, and so on? So this will be the first challenge. Then the maturity of this integration has some challenges at the moment, and it's improving, but you will have to choose Docker images in which we will wire the JNLP agent capabilities. Who is familiar with JNLP agent, JNLP slaves? Okay, so here, let's come back on this. Jenkins has two major protocols to talk to agents, to give orders to agents. The first approach is SSH slaves. So your master is capable of opening an SSH connection to the slave, and it starts the JVM of the slave through this SSH channel. So it's master who opens the connection through SSH to the slave. But there is another approach which is called the JNLP agent, which is typically used for Windows agents, where it will not be an SSH connection initiated by the master, but it will be your agent that will start a virtual machine that will open a socket to the master. So it's the slave, the agent who connects to the master through the JNLP protocol. It's the reason why we call it the JNLP slave. And for this, you need to install on your slave a piece of Java code called slave.jar, and you will have some configuration parameters with the URL of your master, with a secret for the rendezvous. On all this, you will have to inject this on your Docker image. I will give some samples later. Then you will have to deal with the management of the images, and I will show you a sample later. But with this approach, the Docker images are managed in the Jenkins global config. On my previous sample, the Maven image was chosen by the application developer guys, the dev team. And here, I will have to manage the Docker images in the Jenkins global config. It's with labels. It's the same as when you have to manage different flavors of agents with labels. So this will be something that we will have to see, and I will propose solutions. Then there is another challenge, is that usually with these Docker orchestration services, we have a challenge with workspace caching and workspace browsing because these agents are ephemeral. They are wiped out, deleted once they have executed your build. So Usually, you don't have workspace caching for the moment, so it means that you will re-download some stuff for every build, a bit like on Travis or Cloud build services. There is something that is convenient today on Jenkins is the capability to browse a workspace when you want to fine-tune a build script. And here, it may be challenging. So this is a challenge that Jenkins is facing at the moment. And then there is one thing is that Jenkins the cloud is not completely optimized for this kind of workload because the cloud APIs that we have in Jenkins to provision agents has been designed for the edges where this cloud API were VMware machines or EC2 Azure machines. On these machines took minutes or dozens of minutes to be initiated, to be launched. So there is a whole set of optimizations in the build queue of Jenkins to assume that it takes time to start a new agent. When with Docker agents, these are one-shot agents, so we use it for one job and then we wipe out, which is a different behavior, and they are very fast to be allocated. So there are a set, the build queue in Jenkins has to be revisited to be optimized for this type of agents. And another thing is that when you configure agents, you can define 1, 2, 3, 4, 5, 10 executors on each agent. And when you are on this kind of Dockerized agent, one agent equals one executor because we want to benefit of the isolation. So this is new, and we are working, the Jenkins community is working at the moment to improve this integration of a short-lived fast access build agent. Okay? These are challenges, but this doesn't mean that it's a wrong solution because we see that many, many people use this kind of solution today. If you look on the Jenkins plugin portal, you will see that there are hundreds of people using ECS, Kubernetes, Swarm, and so on. Okay? The benefits that you can get from this approach is that when it's set up, it's very easy to manage the infrastructure because you have your Docker orchestration service, Jenkins is connected to it, and if you want to scale up or to scale down, you just have to add one server, physical server, to your Kubernetes or Mesos cluster or to remove it. But you have first a challenge to install it. Then you have a great scalability. As I have said, it's easy to add and remove physical servers to a Docker orchestration service. And you have a great, the last but not the least, is that you have a very good build isolation because you are sure that each build is running completely isolated from the others and is built from scratch. Who in this room is often rebuilding from scratch its project to be sure that there is no interdependencies between snapshots, Maven local repositories? Some people are doing this, yeah. So here you would have it all the time, and you're absolutely sure that there is nothing else running on the platform that could interfere, and that you have every time a pristine environment. Nobody could have done an SSH and install anything. Okay? So these are great benefits that you would get with this approach. On this build isolation, you don't have it with the first approach that I have proposed because you are still on a raw Linux server. So the implementation, as I have said, you can have Kubernetes, Mesos, Amazon ECS, Docker Swarm. Docker Swarm, it's a bit challenging at the moment. There is a challenge. I think that there is a bug with the latest version of the Docker engine. But the other one, they work very well at the moment. On Docker Swarm, if you pick the right version of the Docker engine, it will work. If you can see here, it's a configuration screen for the Amazon ECS service. And typically, what you have to do, you enter your credentials to connect to your Docker orchestration service, and then you have the concept of slave templates. So it will be very similar for all these orchestration services, where you define your Jenkins label to select, to let the project team select what they want, and you will specify your Docker image. Then something which is different from the standard build agents, the Linux, Windows build agent, is that you will quantify the quantity of memory and the quantity of CPU that you allocate for this build. Okay? I told you earlier that there were challenges with managing the configuration of multiple masters, and that you have to set up your Docker orchestration service and so on. So here, I will take my CloudBees hat, and I will suggest you one solution to solve these problems. CloudBees has its private Saas edition offering. If you have attended to the keynotes or to other presentation, you may already have heard of it. On here, we provide a solution where we integrate all these features together until we solve the problem for you. This is one way to Dockerize your Jenkins platform, but there are other solutions, as I have mentioned earlier, Kubernetes, Mesos, ECS, and so on. One quick note, as we have this diagram where you can see the masters and the agent on the same diagram, please do not try to collocate masters and agents on the same Docker host, because the behavior, the requirements on the file systems are very different. You may have experienced this with virtualization. If you try with VMware virtualization and stuff like this, to have masters and agents builds accessing to the same file system, it will go bad, because the way masters access to the file system is very different from the way your builds access to the file system, and you would have also logs of your builds that would continuously purge the cache of the file system, the buffers of the file system, and you would severely damage the performance of the masters. So one tip on this, it's with Docker, you think that you can put every workload everywhere. If you are system administrators, you know that it's not like this with file system on disk access, so don't forget this. Any question on this way to manage, to Dockerize masters on agents? Yes? Sorry.
Does this give us any way to share our slave resources between
Okay. So the question was, is it a way to share slaves between two masters? Please let me take my CloudBees hat first. CloudBees Jenkins platform has a federation service, which we call CloudBees Jenkins Operation Center, that does the job, but in fact, you don't need. Because here, we see if you connect your various masters to the same Docker orchestration service, here ECS, or it can be Kubernetes or whatever, they can all connect to the same Docker orchestration service, and then they will share the physical resources. So this will be solved. If you use Mesos, Kubernetes, ECS, Swarm, it will be solved, because you would connect all your masters to the same orchestration service, and then this orchestration service is in charge to spread the workload when needed. And it's what we do in CloudBees Jenkins Operations PSE, Private Saas Edition. All your masters, we use Mesos internally. All the masters talk to Mesos, and this Mesos manage physical resources, and this is where all our build agents work. Is this, yeah, this clear? Any other question? No? So now I will spend some time about customizing the build agent. It's not really specific to Dockerized environment, but it's required in Dockerized environment. We talked about the credentials, the tools, and so on. And it's a topic that I like a lot, so I spend some time on it. First thing that we want to customize on the build agent is the tools. Why? These tools, they can be a JDK, a given version of Maven, but two different teams will have different versions of Maven that they use. They want Node.js, they want Meg, they want some tools to deploy, like Terraform, Packer, the AWS CLI. Every application team will need different tools. We could, in the past, what we could do is to say each team will have its own slave where they will be able to install everything they need. But then we are wasting a lot of CPU capacities, a lot of hardware. So what we try to do is to have general purpose build agents that I could share between my teams. Okay with this? So as we said, compilers, build tools, deployment solutions. So this is the reason why I want to manage tools externally from the hardware itself, the build agent. How did I did it before, until now? It was a Jenkins tool installer framework. You may be familiar with it when you define a new JDK or a new version of Maven. Who is using, for example, the Maven plugin? With the Maven jobs, you have to define your Maven installation. Is somebody using it? Okay, so you are familiar with this. So, and you will find it for Node.js, there are tons of installers now in Jenkins. There were many benefits. For the Jenkins admin, you were confident that the tool could be installed without any task from your side. So this was very nice. You could compose installers together. One team wants JDK 7 with Maven 339. One other team wants JDK 8 with this same Maven. And this team now, they also want the AWS CLI. And it was very easy to compose all this. And you didn't have licensing issues. So if you want to use the Oracle JDK instead of the Open JDK on your build agents, a solution provider cannot ship the Oracle JDK. But as the download was done through Jenkins, it was you, the user, who did this download. Jenkins asks you for your Oracle credentials, and then it was done. So we had no licensing issue. Maybe you didn't think about it, but it will be a challenge later with Docker. So this is why I mention it now. But there were a challenge that the installer were quite fragile. For example, AWS CLI or is a Python-based CLI. And the way you install a pip Python CLI tool package on Ubuntu, on Red Hat Enterprise Linux, on macOS, and on Windows is not the same. So maybe the plugin developer has missed one point, and you will face issues. So this was how we defined build agent tools in the past. You also had the capability to define your own build tool, own tool. And then in the UI, this is a Maven build. You could select your Maven version, or you could select your JDK version. This is all the things that we could do with tool installers. And this helped us to add general purpose Linux servers that were agnostic of the type of build on top of them. Now, this has changed. Sorry for this. I love the tool installer. I spent a lot of time. But now what we are doing is the idea to rely, we say, if we have Dockerized build agents, then we will leverage the capability of Docker to install softwares. We will leverage this capability to customize the build environment. And so here we will find the Docker image of the tools that we want to use. And this is, there are many benefits. It's no longer fragile, because I no longer have to be sure that it works with Ubuntu 14, on 16, on RHEL, and so on. So this was a great benefit. On all these tools that we like to use to develop, they are already available on Docker Hub. You will find an Azure guy will have done an Azure CLI image. Apache Maven, they maintain their image, and so on. So everything is available, implemented usually directly by the developers, the owner of the tools that you want to install. But now there is a challenge. One challenge is how to combine the tools. So I've showed you there is a great Maven image. But maybe in my Maven job, I am invoking Selenium with Firefox to do some tests. So I need an image. I need to be able to have simultaneously Maven on Selenium on Firefox 42 or 44. So how do I combine the tools? If you have written your own Docker file, keep in mind that Docker files use inheritance, but you cannot, it's single inheritance, it's not multiple inheritance. So you cannot compose 3 images. You cannot extend 3 images. So this will be a challenge. Then if you introduce these Docker images, you have a challenge to govern these Docker images. You are a Jenkins admin, you have all your governance model for your slaves, and now you will have to choose a governance model for the Docker images. So this will be a challenge. You may have some licensing issues. On here, we had a funny story. For a while, Oracle JDK was available as a Docker image on Docker Hub. Somebody published an Oracle JDK image on Docker Hub, and many people were extending this. Unfortunately, or it's like on YouTube with copyrights, but somebody said, no, it's not allowed. The licensing terms of the Oracle JDK does not make it possible to make a publicly available Docker image with Oracle JDK. You may find this issue with other tools that you like that have maybe commercial licenses or open source business and friendly licenses. So maybe some licensing constraints will make that the tool that you want is not available on Docker Hub, and so you will have to create your private own image. And typically, on Docker Hub, you don't have Red Hat Enterprise Linux images. You will have to look at the Red Hat registry to find them. So it's something new to deal with. And then I've mentioned earlier the JNLP agents. If you want to use these Dockerized solutions in a Docker orchestration service, you will have to use JNLP agents. And so on top of this image that you want to use, you will need to add this slave.jar on all this plumbing to connect back to the master. So you will have to create your own Docker image to do this. Maybe to create your own, or maybe somebody has done it for you. So these are some challenges. And I will propose you an answer to help. CloudBees has started last January a Docker image that we call Java Build Tools. It's open source, freely available, where we have combined many tools. So we said that it's a challenge to combine tools. So we have worked at combining tons of tools together that are relevant for Java builds and that you will be able to use in your environment. So we have started this in January 2016. Now it's a version 1.0. We tried our best to document this well. So you can see it's Ubuntu 15. We have installed OpenSSH client, wget, curl, git, AWS CLI, Azure CLI, Bower, Cloud Foundry, Firefox versions 43, JCC, Grunt, Gulp, OpenJDK 8, which was a 45, JMeter, Kubernetes, Make, and so on. MySQL also, because it's convenient to do some database tests to access a database in your builds. So we have done this image. It's convenient for many use cases. The drawback of this image with tons of tools pre-installed is that it's quite fat. But it's not a lightweight. It's not a debate between Debian image and Alpine image, because we have installed so many things, but it's convenient. So we think that it's a good, it helps. We have a good traceability. You can use latest, or we have fixed version so that you are sure that you have no regression, because all the knowledge, best practices to manage Docker images is something new, and it's evolving. So we have made some choices to be very strict. People can find it painful. Our process is longer, but at least you are sure of exactly what version of Firefox you will be using, or things like this. And then what we like with Docker files on Docker images is that you can very easily fork what we have done and create your own image with what's in here. Okay, I will have to accelerate a bit. And then we propose also a JNLP slave-based image for this. Now, how to manage credentials on configuration file. First, I would recommend nothing on disk, nothing on the build agents. To manage credentials, you have the Jenkins credentials capability storage, and here you can see a screen of it. It has been greatly improved recently. And to manage configuration files, typically you have the Jenkins configuration file provider. It's a plugin. The key contributor is Dominique Bartoli, and he's here this week. And it will help you to manage your Maven settings, your Gradle settings, any kind of configuration files that you need to deploy on your build agents for your builds. So here is some things that you can do with these credentials capabilities on config file providers. If you want to have a login password in your build environment, you will use the with credentials binding, and you will source your login and password, maybe database login and password, with environment variable or on a file on disk. This is for login password. Now this can be for AWS credentials, IAM credentials. We know you don't even have to declare the environment variable names for the access key and the secret key, because we know that the default one are AWS access key, AWS secret key. So you can omit this, it's very compact, and then you can use the AWS CLI. You need to inject a Gradle configuration file. Then you have this config file provider. You just give the file ID, which is my Gradle config. You will store it on as a Gradle.properties file, and this plugin will ensure that it is copied at the beginning of this wrapper and that it is safely deleted at the end of the execution. At the end of the execution, no more credentials on your environment. Maybe you want to use something with Maven, with this Maven settings.xml that we have discussed earlier. Here it's a Maven pipeline plugin. You do with Maven, you specify your Maven settings config file, which is managed by the config file provider, and it's transparently injected in your Maven invocation. It also works with JFrog new plugin for pipeline. You may want to manage an SSH key to do an SSH access. Here, it's the SSH agent, and you define the SSH keys that you want to make available, and you can do an SCP SSH is here. Done. So these were solutions. These are the solutions I feel that make it easy today to have general purpose build agents. It's even more important in a Docker context, but it also applies to Linux standard slave or Windows or whatever, where you don't have to store any secret, any credential, any config file on your build agent. All this is managed by Jenkins. Okay? I propose to accelerate, and if we have questions, we can discuss this later. Managing Docker images is very important, as we've seen, because application team will choose their image to build. The requirement that we want is a flexibility for the Jenkins users, the developer, to pick the image that they want. But we have a constraint is that sometimes the Jenkins admin will want some sort of control on this. And I propose you a governance model. Every organization has its own constraints, but here what I propose is that we have a shared governance between the Jenkins admin and the application teams. And we will share this governance with the Docker files. These Docker files are text files with inheritance. And I propose to store this Docker file in Git repositories. We can have pull request mechanism to have this governance implemented with reviews and validation by the control guys on things like GitHub Enterprise, GitHub or GitLab or Bitbucket can help on this. And then typically what we can do is that the Jenkins admin will control the base Docker image, and they will let the Jenkins developers, the user, choose the tools that they install on this base image. This is a kind of governance model that works in many organizations. We still have a challenge with Dockerized agents. As I have said earlier, when you have Dockerized agents with Kubernetes, Mesos, Swarm, ECS, the images are declared in Jenkins global config. It's not in your pipeline, it's in the global config that is controlled by the Jenkins admin. And so here what I've seen successful is to create some kind of alias as Docker images. You create a Docker image that is the name of your team, the name of your build. And this image will inherit from the image that really does the work, and so that you will not have to update all the time your Jenkins config, where you have to go through the Jenkins admin, but it's the application team that will be able to enhance the Docker image, do its Docker push to push a new version of the image, and as we are based on the latest version of this Docker image in the Jenkins configuration, it's a way to distribute newer version or changes of the Docker image. It has pain points. CloudBees Private Saas Edition has proposed another way to solve this, but keep this in mind if you face this issue, this idea to have alias images that are kind of have an immutable name, and then to put the real stuff in a Docker image that you inherit from. So typically, you have to keep, this is what you can do as your image where you put your tools. You inherit from Jenkins GNLP slave, and you will have some tool installer commands to install Maven on things like this. So the learning curve is not very big, but it should not be undermined. Okay? If we talk about Docker images, now we have to talk about the way to manage these images, and this is the role of Docker registries. I'm sorry I'm running a bit late, but I'm accelerating. So the Docker registry, you use it to pull the image that you use to customize your build environment, so the Docker image with your tools. You will also use the Docker registry to pull image when your build job is creating new images because you ship your application as images. Maybe you will have to pull the Tomcat image so that you compose your WAR file with Tomcat. So this is another reason to pull image, is to build other image. Then you will push images when you create images in your builds because you ship your applications as Docker images. And another interaction that you will have with your Docker registry is to be notified when there are images that changes because you may want to trigger downstream jobs. These are the types of interactions that we have with the Docker registry. The first thing that I propose you is to start small and to start with Docker Hub, which is an online Docker registry. You just have to enter your credit card number, and it's easy, it's here. So you will do all your pulls, your push, and the notification with Docker Hub connecting to the internet. The challenges that you may face are security, network, and sometimes, as I've said for the Oracle JDK image, Docker Hub may remove some images, and so that your image may become invalid. So be careful if you inherit from images produced by somebody else, but you don't control what Docker Hub will do. It's not a difficult problem to solve, but you will have a lot of benefits. You don't have to choose the software, and the management that you have to do is very limited because it's a software as a service. Maybe you will have to go through proxies, but you can configure all your infrastructure, all your Docker engines to go through proxies. Be careful, Docker Hub does not have fixed IP address if you have to configure firewalls because they are based on Amazon ELB, and Amazon ELB doesn't tell you which IP address is used. So be careful if you have firewall constraints, it will be hard to know which image you use. Then the next step usually is to have your own private Docker registry. So this Docker registry, typically, they can be provided by Docker Inc. It's the open source version of Docker Trusted Registry. Amazon ECS, ECR, Elastic Container Registry. JFrog was one of the first registry available. Nexus, Sonatypes, they also have a Docker registry, so you have many solutions. And typically, this Docker registry can be seen a bit like a Maven repository in your organization. It will act as a proxy to pull official images from Docker Hub or maybe from a Red Hat Hub. And it will be also the registry for your homemade images. So all your Jenkins platform will talk to this private Docker registry. And this Docker registry will be a pass-through proxy for the pulls that you do from directly from Docker Hub content. Okay? So here you will have some challenges because you will have to choose the products that you want. You will have also to manage disk space, but usually if you have played with Docker, it's very easy to have a file system full, creating too many images. So the new Docker Trusted Registry is supposed to have solved the file system usage challenges that they were facing, and I don't know exactly how it worked for the other solution. Please don't forget, it can be a challenge. Okay? How to start? So first, you will have to choose how you Dockerize your Jenkins infrastructure. I propose you two approaches. First is you install the simple Docker engines on your existing Linux agents. Very simple and iterative approach. Or I wear my CloudBees hat, and I recommend you to look at CloudBees Private SaaS Edition. Once you have chosen your Jenkins infrastructure, how to Dockerize it, the Docker images, the CloudBees Java Build Tools image can help because it covers many use cases already, and it probably helps to fork this or to copy-paste some fragments to create your own image, or you can find other images on Docker Hub. And then another very important part of this Dockerized infrastructure is the Docker registry, and I propose you simply to start with Docker Hub, and then you will look at private registries. So this was my proposal to Dockerize your Jenkins platform. I see many benefits, some challenges. Thank you, and I will now, please feel free to ask for any question. Sir? Sorry?
While creating Docker files for Jenkins Masters, we need to make security patches for OS 0-day vulnerabilities and ARE vulnerabilities.
Okay, so the question is, when I create a Docker file for my Jenkins master, how do I support patches for 0-day fixes? And here I would extend the topic. It's the same problem for people who decide to package applications as Docker images, where, for example, you ship Tomcat with your web app. What happens with a 0-day? And here what I would recommend you is to have a very good continuous integration platform that is able to very quickly build the new Docker image with a fix. And typically, it's a problem that OpenShift is trying to solve with their source-to-image solution, where an infrastructure admin can pretty easily rebuild the images even on Christmas Day or whatever. Another question?
Yes, when you said just give your credit card, is that for security or is that because they'll charge us?
No, it's Docker Hub. They ask for your credit card to charge you if you want private images. How do you restore your Jenkins config if you upgrade the Docker image? So here, when you use Dockerized applications, the file system, if the file system used by the application is in the Docker container, it is ephemeral and it's deleted. So here you use Docker capabilities to do bind mounts to mount file system, and it's clearly documented on the CloudBees Jenkins Enterprise Docker image or on the Jenkins open source Docker image, the command lines that you will find will do the file mount, and you will understand how you rely on the underlying host to store the files. Any other question? No? Thank you for your time.